Assalamu alaikum dear students. Today we are going to discuss how to find the length of lattice rectum of an ellipse. Now if we consider an ellipse x square upon a square plus y square upon b square equals to 1, that is the ellipse whose major axis lies on the x-axis, or simply the foci lies on the x-axis, that is this. It has two foci, that is f1 and f2. Now the line segment which passes through this f1 and or f2 perpendicular, that is perpendicular to this major axis with its endpoints lying on the ellipse, such very line segment is called as the lattice rectum. So here we have two lattice rectums. One, it is AB because this line passes through f1 and perpendicular to the major axis with endpoints A and B lying on this ellipse. So it is one lattice rectum, and second one is CD because this is the line segment passing through F2 and perpendicular to this major axis. Now how to find its this length? Now let's say that AF1, that is this one, is L. Then the coordinates of this point are CL because distance of this focus from the center is C or minus C. Also we know that the eccentricity of an ellipse is C upon A, which implies that C equals to AE. Hence the coordinates of this point A are AEL. AEL. Since A lies on the ellipse, which implies that the coordinates, that is AE and L, should satisfy this very equation, x square upon a square plus y square upon b square equals to 1. So on substituting in this, we simply get e square plus l square upon b square equals to 1, which implies that l square equals to 1 minus e square into b square. But again, this e equals to c upon a, which implies that e square equals to c square upon a square. So substituting e square in this l square, we get l square equals to a square minus c square upon a square into b square. Also c square equals to a square minus b square, which implies that l square equals to a square minus a square plus b square into b square upon a square, which simply equals to b raised to power 4 upon a square. Hence L equals to b square upon a, because by taking roots on both sides and considering only the positive this positive sign, because it is the length, so we take simply the positive sign, that is L equals to b square upon a square. This parabola is this ellipse is symmetric, which implies that length of AB, which is the lattice rectum, is twice L because it is symmetric with respect to the coordinate axes. Hence it is 2L, that is twice b square upon a square is the length of this lattice rectum AB or CD. So simply we say that the length of lattice rectum is twice b square upon a square. So we will take now the questions from this exercise, the second exercise, which is about ellipse. Now find the vertices, foci, length of the major axis, minor axis, eccentricity, and the length of a lattice rectum of the given ellipses. Now the first one is x square upon 36 plus y square upon 16 equals to 1. Here the denominator of this x square is greater than the denominator of this y square, because it is 36 is denominator of x square and 16 is denominator of y square, which implies that the major axis, because major axis is always greater, length of the major axis is always greater than the minor axis, which implies that the major axis or the foci lies on this x-axis. So comparing this equation with x square upon a square plus y square upon b square equals to 1, we simply get a square equals to 36, that is a equals to 6, b equals to 16, that is b square equals to 16, that is b equals to 4. Now the center of this ellipse, x square upon a square plus y square upon b square equals to 1, is 0 0, which implies that the center of this very ellipse, given ellipse, is also origin. Now the foci of this very ellipse x square upon a square plus y square upon b square equals to 1, and they lies on this x-axis, which implies that their coordinates are plus minus c 0, where c square equals to a square minus b square, which is simply root 20. Hence the coordinates of foci of this very ellipse is plus minus 20 0. Now the vertices means endpoints of the major axis are plus minus a 0, that is plus minus 6 0. Now the length of major axis, here a is the length of the semi major axis, which implies that the length of major axis is twice a, that is twice 16 equals to 12. Similarly, length of the minor axis is twice b, that is 8. Now the length of Latus rectum equals to twice b square, that is square of the semi minor axis upon the semi major axis, that is twice b square upon a square, that is simply 16 upon 3. And the eccentricity of ellipse is c upon a, that is root 20 upon 6. So in this way we find all the coordinates and all the features of this very ellipse. Now consider the ellipse whose foci lies on the y-axis, that is x square upon y, this 4 plus y square upon 25 equals to 1. Here denominator of this x square is less than the denominator of this y in this y square, which implies the major axis is along y-axis. So comparing this with x square upon b square plus y square upon a square is 1, we get b equals to 2, a equals to 25, and c equals to a square minus b square, that is 21, which implies that c equals to root 21. Now the center of this any ellipse is origin, that is 0 0, which implies that the center of this ellipse, given ellipse, is 0 0. Now the foci of first, that is this very ellipse which lies on this y-axis, or 0 plus minus c, its coordinates of the foci, or plus 0 plus minus c, which implies that 0 plus minus root 21, that is 0 root 21 is 1 folks, and 0 minus root 21 is the coordinates of second focus. Now the vertices of first, vertices are the endpoints of major axis. Major axis is along y-axis, which implies that the coordinates are 0 plus minus a, that is 0 plus minus 5. Length of major axis is 2a, that is 10. Length of minor axis, that is 2b, which is 4. Now the eccentricity of ellipse is c upon a, that is root 21 upon 5. Now the length of Latus rectum equals to twice b square upon a. It is for any ellipse, whether its major axis is along y-axis or x-axis. It is always 2 times square of this minor axis upon the square of the semi-minor axis upon the semi-major axis. Length of semi-major axis is here a, it is simply 5, and length of semi-minor axis is b, which is simply 2. So in this way we find all these. So inshallah in tomorrow's video lecture we will find, or we will derive the equation of the ellipse when certain conditions or certain constants are given. So thank you.